Hey guys, we are from group KK1 and our integrated project is about production of ABE for fuel from bacteria. My group members is myself, Muhammad Muaz, Nur Amalia, Nurul Izzah and Wong. So what is ABE? ABE is a combination of acetone, butanol and ethanol. ABE is a promising fuel produced from petrochemical industry intermediate. ABE fermentation started in China in early 1950s in Shanghai and expanded thereafter. We chose Clostridium basinski because it has the highest yield compared to others. Usage of ABE is in fuel industry, beverage, fashion and medical industry. But we chose fuel industry since it has the biggest percentage. Economic analysis of ABE. As estimation at 2022, supply of ABE is 1,109.46 kilotons per year and demand is 1,153.84 kilotons per year. Our plant capacity produce 44.378 kilotons per year and that is equal 105.7 kg per hour. We decide to contribute 2% of global demand. Our plant will operate continuously for 350 days with 2 weeks of break. Process description of ABE. We'll start with pre-treatment of lignocellulosic biomass. We decide to abstract this process from corn stove. This process will continue by enzymatic hydrolysis of cellulose into glucose and pre-fermentation with Clostridium basinski. The main process of production of ABE is ABE fermentation with Clostridium basinski. This process will end with filtration to remove cell biomass and recovery of acetone, butanol and ethanol. I'll pass the next part to Nurul Izzah.
Thank you, Muaz. So, this is our process flow diagram, which shows more details about our process description before. Now, we move to the next slide. There are 3 parts of biosafety issue on Clostridium basinski, which are before using, during using, and after using. For the first part, the preserved spore suspension was being stored in a sterile distilled water at 4 Celsius. Then it was activated by heating and cooling process. It was then placed in a sterile cooked meat medium right away and incubated for 16 to 19 hours. During using, the bacteria went through the fermentation at temperature of 37 Celsius with 150 rpm agitation rate. For the last part, after the reaction happened, waste from Clostridium basinski combined with all the wastewater to the treatment process. All the equipment that being used before will get sterilized and ready for the next process. Next slide. This is the safety environmental issue for our waste. For acetic acid in wastewater, we must wash our hands properly after using it and make sure to wear proper attire with SOP. Same goes to butyric acid. It should be stored in tightly closed container in cool and well ventilated area. Make sure to remove all the potential ignition sources. For water, there are no specific storage and handling procedure required. Next, for our waste gases, it should be avoided from using and being kept in closed tightly container. Lastly, for our cell biomass, proper attire with SOP should be wear and make sure to be trained in managing contagious biological material to handle it. Next, waste treatment method. For waste gases, gas purification is the best treatment that we choose, and it can be disposed in a variety of ways such as recycle and absorption. As for the wastewater, it was treated by anaerobic digestion and it can be neutralized by alkali activated materials. For cell biomass, it was sterilized before being treated, and normally it can be disposed in landfills or in open landfills. Now, I'm passing this session to Amalia.
Thank you, Izzah. Now, I will continue the presentation. First part is mass balance. First, we use an example of mass balance fermentation system in the fermenter. The total input flow rate is balanced with total output flow rate. While the mass balance for the whole system, the total input and output flow rate are balanced. Next part is energy balance. We take the main fermenter as an example. Above, the table shows the heat of combustion of the respective compound that found in our fermenter. The heat of reaction we got is negative 1.323 power of 7 kilojoules per mole. The heat of reaction we calculate is negative, so the heat will be released and the fermentation is an exothermic reaction. Next is biochemical equilibrium. The equilibrium constant K is a relationship between product and reactant at equilibrium with respect to particular unit. By calculation, at temperature 310 K and reference temperature or T0 is 298.15 Kelvin, the K we get is 2.169 power of 5, which is K is larger than 1, so the reaction will favor production of product. Our reactant and product are in liquid phase, so we assume both as an ideal solution. By trial and error methods, we get epsilon is 3.312 kmol per hour, while by using Microsoft Excel Gold Seed functions, epsilon we get is 3.312 kmol per hour. Both results are consistent. Then we substitute the epsilon into composition equation. The total of composition equation is equal to 1, so it is verified. The percentage of difference is 0.022%. There is only an insignificant difference between the mole fraction calculated by epsilon and the mole fraction calculated by mass balance. Next, I will introduce our producer cell. Our producer cell is Clostridium beijerinki. The ladder shows the taxonomic classification of C. beijerinki. First, the domain is bacteria, phylum Firmicutes, class Clostridia, order Eubacteriales, family Clostridiacea, genus Clostridium, and species Clostridium beijerinki. Now, I will let you Song to continue the session.
Thank you, Ahmad. Now I will continue Ahmad's session on cell biology tasks. The type of extracellular metabolic pathway can be separated into two phases, that is, acetogenesis and solventogenesis. In the first phase, acetate, butyric, and carbon dioxide are produced as major products, while in the second phase, acids are re-assimilated and transformed to solvents such as acetone, butanol, and ethanol. The optimum pH range should be 5.5 until 6.5, while the optimum temperature should be 37 degrees Celsius. Next, we choose corn stover as our primary carbon source since the fermentation of corn stover by bacteria Clostridium beijerinki can produce the highest ABE yield, titers, and productivity as shown in this table. Among of all the medium to cultivate the bacteria, we choose P2 medium with composition as shown in this table because this medium could assist the high ability of bacteria in ABE production. In task fluid mechanics, we choose the centrifugal pump P201 that connects the filter and the heat exchanger as our control volume. We compute and perform total friction loss, mechanical energy balance, suction heads, discharge heads, and performance curve graph by referring to Gyan-Copley's book 5th edition. We found out that the MPSH level is 7.0466 meter with pump efficiency 49.72%. Our estimated pump power is 2.722 kilowatt. In conclusion, ABE is a promising field and it is important as one of the approaches for green energy in aligning with SDG. We choose lignocellulosic biomass corn stover as our raw material. The bacteria Clostridium beijerinki is chosen due to its high productivity of ABE. The pump process could be separated into three stages that are pre-treatment of corn stover, fermentation, and recovery of ABE. Waste generated are a mixture of the wastewater, waste gas, and cell biomass. We also found out that the fermentation process is exothermic since the heat of reaction is lesser than zero. By using concept of biochemical equilibrium, we found out that the equilibrium composition is almost similar to that of the material balance. Besides, selection of bacteria, carbon source, and medium cultivation is based on the ability to obtain the highest ABE. From calculation, MPSH available for pump is 7.0466 meter with 49.72% efficiency. That's all from our group KK1. Thank you for lending me your ears. Bye bye and stay safe.